Hello all. In today's video we're going to be talking about evaluating functions. So whether that function is given in an equation form, in table format, a graph, etc. We want to be able to evaluate all those different functions. Also, if we're given the output, can we find the input? So let's review for a minute. We have this function notation here which says f of x. So again, this is just naming the function. It's giving it the name f. It's telling you that the input is x, and this whole f of x is actually y. So f of x is the same thing as y. So in our ordered pairs, x is the input, and f of x would be the list of all the outputs, all the y values. Now, in this first example, we are given different equations, and we can determine which one we need by the name. So this one says g of 0, and that's saying input 0 wherever you see an x and figure out the y value. So using this first equation here, g of x equals 4x plus 5, everywhere I see an x, I'm going to replace it with 0. And whenever we have a number next to a variable, that's multiply. So this is saying 4 times 0 plus 5. So in this function, I'm taking x, multiplying it by 4, and then adding 5. And we want to know specifically g of 0. So when I plug in 0, what happens? Well, 4 times 0 is 0, plus 5 is 5. So g of 0 equals 5. And do the same thing with function f. So now I'm using the second function here. And everywhere I see an x, I'm going to plug in 2. So 3 times 2, that quantity squared, minus 2, plus 2, right? So every place we saw an x, we're filling in the value of 2. The input was 2. And I want to know the output. I want to know what y equals. Following order of operations, I'm going to square first. So 2 times 2 is 4. And 3 times 4 is 12. And then, we could have done this a long time ago, but minus 2 plus 2, that is 0. If I subtract 2 and I add 2, I've added nothing. So overall, this is 12. So f of 2 equals 12. That means this is basically giving us ordered pairs on the function, or in the graphs of the function. So this one, I would input 0 for x, and I got an output of 5. So x was 0, g of 0 was 5. Sorry, got a bug in my throat or something. On the second one, we input 2 for x, and we got out 12 for y, right? f of x is y, so f of 2 is the y value when the input was 2. Same thing here. Now I'm going back to g. So now I'm plugging in negative 5. So 4 times negative 5 plus 5. 4 times a negative 5 is negative 20 plus 5 would be negative 15. Same thing down here, plugging in into f of x, plugging in negative 1. Now I recommend whenever you have negatives, putting parentheses around wherever you're plugging it in, so you make sure you don't lose that sign anywhere. So 3 times the quantity negative 1, that x is being squared, minus, we're plugging in negative 1. So right there, that's one of the places that negatives could get lost. I have a negative here in the original equation, and I'm plugging in a negative. So just be very careful with your signs. So exponents first, negative 1 times negative 1 is a positive 1. I would multiply next. So 3 times positive 1 is 3. And then I could also think of this as a negative times a negative. So it's going to end up being positive 1. Whenever I subtract a negative, I'm going to add. So now I've got 3 plus 1 plus 2, and I end up with 6. Now in this next example, it is plugging in a quantity, an expression, not a single value. So now wherever I see an x, I'm plugging in all of this, x plus 1. I'm not going to get a single number value. So be careful with that. All of this has to go in for x. So I have my 4, and instead of x, I'm writing x plus 1. Still plus my 5. Order of operations here, I'm going to distribute, because I can't add x and 1. Those are not like. So 4 times x is 4x, 4 times 1 is 4, plus the 5, and all I can do is simplify. I can't get an exact value here. So simplify by combining my like terms. 4 plus 5 is 9. And that's as far as I can go with that. Okay? So g of x plus 1 is 4x plus 9. Here I just threw this one in because it's like your homework. You've got a fraction that you're inputting into a fraction. So I'm going to review that, make sure we're all on the same page. So wherever I see an x, I'm putting in 1/3. So 1/3 in the numerator, 1/3 in the denominator, and then overall subtracting 2. So I have to simplify the denominator first. I have to have a single number being divided by a single number. So if you have forgotten, we have to get a common denominator. So I'm going to put this whole number over 1, and the LCD of 3 and 1 is 3. So I'm going to multiply by 3 over 3, which gives me, just a little side work over here, 1/3 minus 3/3, which that makes sense. 3/3 is the same thing as 1. So 1/3 minus 3/3, we subtract the numerators, keep the same denominator. So 1 minus 3 is a negative 2 divided by 3. And now I have a fraction divided by a fraction. So the way we divide fractions is to multiply by the reciprocal. So again, I'm just going to do some side work over here. And I'm going to say 1/3 divided by negative 2/3. That's the same thing as 1/3 times, so multiply by the reciprocal, negative 3/2. Okay, so the way we divide fractions is copy dot flip, multiply by the reciprocal. So now I see if anything divides out. 3 divided by 3 divides out. I multiply across the numerator. 1 times a negative 1 is a negative 1. Multiply across the denominator. 1 times 2 is 2. So you end up with a negative 1/2. So negative 1/2 minus 2. Same thing, I'm going to put this over 1, get a common denominator. So between 2 and 1 it's 2. And multiply by 2, numerator, denominator. So negative 1/2 minus 4/2. Again, that makes sense. 4 divided by 2 is 2, which is what we started with. And overall, subtract the numerators. Negative 1 minus 4 is negative 5. All over, the denominator stays the same. So I can write it as negative 5/2. Or, since that's improper, I could change it to negative 2. 2 fits in there twice, with a remainder of 1. So either one of those would be acceptable to me on a test. Alright, let's keep going. So determine x when g of x equals negative 3. So now this is giving us g of x. So in this original equation, I'm going to replace g of x with negative 3. So negative 3 equals 4x plus 5. So this does not mean g times x. This whole thing is saying find x, so find the x, the input, when the output is negative 3, when the y value is negative 3. So we're just replacing g of x with negative 3, and now we need to solve for x. So I'm going to subtract 5 from both sides, get negative 8 equals 4x. I want to get x alone, so I divide by 4. So negative 2 equals x. So replacing g of x with negative 3 and then solving for x. Alright, let's try some different types. Those were equations. What if I have a graph? So this graph tells me everything I need to know to find these answers. So this says we want to find f of negative 2. So again, that's saying when x equals negative 2, what is y? Okay, f of negative 2 is y. So looking on the graph, when x is negative 2, what is y? So x was negative 2 on the x-axis. What is y? Y is negative 1. Now we're saying when x equals 3, when the input is 3, what is the output, or the y value? So again, I go on the x-axis to 3, find where that point is on the graph, and the y, how far up and down, it's not moving up or down. So the y value is 0 here. Alright, that's a terrible 0. Alright, these next two are saying, now, when y equals 1, what is x? So on the y-axis, I go up to 1. Now notice that I have a y value of 1 here, and a y value of 1 there. So there are two different y values that it could be. So when f of x equals 1, so when y equals 1, x could be negative 4, or it could be positive 4. So we used the y-axis to find that, and then looked at the x and said what could the x values be. Same thing here. It says find all values such that f of x equals negative 2. So f of x, that's y. When y equals negative 2, what is x equal? On the y-axis, negative 2. So we've got this point at that height, and this point at that height. So x could be negative 1, and x could be 1. Okay, so when we have the output, the y value given, it is possible to have two values, but if we're finding the output given the input, there should only be one, if this is really a function. So these should only have one answer. This could have one or more, because we're given the output and we're finding the input. Okay. Here I have a word problem. Now, I noticed that this was not on your homework, but this is something that could be on a test or a midterm. So, or the final. So this is something that you do need to know. The application problems of functions. This says the function f of x equals 0.55x plus 3/10 approximates the number of students enrolled in an online class in millions. Given x is the number of years since 2000, approximate the online enrollment in fall 2008. Okay, so x is the number of years since 2000. So if we're doing 2008, the number of years since 2000 would be 8. So we're asked to find when x equals 8, we want to know f of x. Or we're finding f of 8. So I'm plugging in 8 wherever I see an x. Okay, so first I'm going to multiply 55 hundredths times 8, and then add 3/10. I get 4.7. So I still followed order of operations there. And this is 4.7 million. Okay, in general we don't want decimals because we can't have part of a person, but this is 4.7 million people or students enrolled in online classes. So that's okay to leave that decimal there. Alright, so there's an application. You just have to determine what the x value is, being careful. The x is the years since 2000, so I plugged in 8 years since 2000, not 2008 itself. And then plug it in, and then get out the output. Okay, this last one is using ordered pairs or a table to determine these values. So if I wanted to find f of 1, I go up to my little function here, and this is x. So I'm plugging in x equals 1. So I want to see the one where x equals 1. So f of 1 would be the output, or the y value, which is 7. Here, I want to know x when f of x, so when y equals 5. So I see y equals 5 here. So x had to be negative 3. When y was 5, what was x? Same thing down here. So this is the set of inputs, and these are the outputs, the y values. So if I want to know f of, oh, sorry, I changed these values. Let's say f of negative 3. So when x is negative 3, right, because this is saying f of x. So when x equals negative 3, what is y? Y was negative 2. Here I'm finding x given y. So I know f of x, so down here I go down to f of x. I know f of x is 7, and I want to know x. So the x that goes with that 7 is negative 7. Alright, well let me know if you guys have any questions.